let's talk about a conventional installation of a drain field. The majority of installations are going to be of the conventional variety. There's some variables. There's a little bit of differences, but they're all basically the same. You're going to have the septic tank. All the plumbing from the house is going to drain into the septic tank. There's going to be a pipe coming out of the septic tank that leads out to the drain field area. The drain field is a series of pipe in the ground, all connected together. That pipe has holes in it, typically on a 45-degree angle, and those holes allow the water from the septic tank to drain into a bed of stone. And typically in our area, we're going to have 12 inches of stone. And we sometimes hear people talk about, they may have installed their own system and may not have gone through the permitting process, and we hear that they use pea gravel or they used real large stone. The type of stone that's used for drain fields is 6A. So that is the size of the stone, and the stone's going to be about this size here. And the reason that we use that size stone, we want a little bit larger stone. So pea gravel is going to be too small. It doesn't create enough surface area to allow a good growth of bacteria, which we're not going to get a appropriate amount of bacterial action in the drain field to clean that water before it gets back into the ground. So we want a little bit larger stone so we have that surface area. The we can get enough bacteria in there that can handle cleaning of the water that comes out of the septic tank. But we don't want too large of a stone. If we have too large of a stone, we're going to get these bigger gaps in between the stones. So if, say we've got stones that are this size, they're going to be in here this way and then this way, and we're going to have all these large gaps in there where the water's going to get through the stone too fast. We may have a lot of surface area for bacterial growth, but the water may not be hitting all of the stone, or it's going to be coming through too fast where it's not getting the particles cleaned out of it before it gets through the drain field. So 6A, that's the size of the stone that's used in drain fields. Let's talk about how the pipe is constructed. So we've got the septic tank. The pipe from the septic tank is going to come downhill to the drain field, and it's going to come into a header. There's a couple different types of headers. The simple header is just going to come, the pipe's going to come downhill. It's going to come into a T that splits it this way, and then there will be lines that come off of that header. Most of the time between 4 to 8 lines, and those will all be connected together at the back with a footer. So they're all going to tee into another pipe at the other end of the drain field. So the goal of the system is that the water comes out of the septic tank, comes down that line, hits a T, causes that water to spread out sideways through the header, and then push down those lines equally. So ideally this should all be level. The water is going to spread out evenly throughout the entire drain field and drain out of those holes in the bottom of the pipes and get equal distribution through the entire drain field. The reason we want that is to make sure that the entire drain field is getting used, which will allow it to last as long as possible. If all of that effluent comes out of the septic tank, pours into one side of the drain field, and only uses a couple of the lines, we're only going to be using 20 to 40% of the drain field, and it's just not going. Those lines won't take the water as long as won't last as long as if we were spreading that water out throughout the entire system. Um, so I mean, that's the basic construction of a conventional system. Uh, Pretty simple. The only other uh, variation you might get sometimes is the use of a bridal header, and what that's going to be is it's kind of a mini header before you get into the main header of the drain field. So the drain field will be constructed the same way. We've got the header with the lines coming off of it. With the bridal header, you've got the line coming from the septic tank. It's going to come into a mini bridal header, which is going to divert the water to two sides of the drain field. So that bridal header is going to tie into 2 points of the header, and it just guarantees more, better distribution, to making sure that even if that header wasn't perfectly laid level, it's forcing the water to get to both sides and give an even better chance of proper distribution through the entire drain field. One other variation that we're going to see, the drain field that I've been describing would be a bed construction. So the entire area of the drain field is filled with stone, and with the pipe running through it. Trench system would be another variety of a conventional drain field, and it works the same way. You're going to have septic tank draining into a header that's diverting the water. We got lines coming off the header, but instead of having stone throughout the entire area of the drain field, we're only going to have trenches where the pipes are laying. So typically those trenches will be 2 to 3 feet wide, and there will be stone laid only in the trench. So you'll have one trench with stone in it, you'll have an area that's undisturbed, and then another trench with stone and pipe through it, and so on throughout the entire drain field. We don't see a huge difference in longevity between a trench system and a bed system. Typically, permits are going to be written for a certain square footage of stone in the drain field. And so a trench system may take up a little bit larger area than a bed system does. So the bed system can be a little bit more compact because you don't have those kind of blank spaces throughout the area of the drain field. But everything else is working exactly the same way in either one of those systems. So that's the basic rundown of the conventional system. I don't think I mentioned it yet. We've mentioned it in previous episodes, but throughout that stone in the drain field, we're going to get a naturally occurring layer called a biomat, and that's where the majority of the bacteria is going to be present in the stone of the drain field. And again, that bacteria is there to remove the particles that are in the water that come out of the septic tank. And so that by the time the water drains through that stone in the drain field and gets back into the ground, it's a good clean water again. It's not going to contaminate it. It's not going to contaminate any waterways or drinking water below.